Howdy. Okay, so for today, we're going to finish out operations with matrices. You do not need to do the first problem. I think we already did that one yesterday. Just need the second one here. Given matrices A and B, find A plus B and B plus A. And then tell me anything that you notice about the two. Okay. So your grades are 100% up to date now. Yay. Overall, it looks like we did pretty good on that Unit 3 test, with the exception of, did you not do it? If you didn't do it, what am I talking about? I don't think I'm talking about anybody in here. Okay, well, if you didn't do it, you still can. And if there's any homework you didn't do, you still can. Let's do the bell work. So for this one, A plus B, if I add my elements here, -1 plus 1 is 0. And then 5 plus -5 is 0. And then 2 plus -2 is 0. And -6 plus 6 is 0. So you get the 0 matrix. For B plus A, what do you get? The exact same thing. So this tells us, at least shows us an example that matrix addition actually is commutative. Doesn't matter what order you add, A plus B is the same as B plus A. You should also, notice that these two matrices are in fact opposites of each other, since they make the 0 matrix. Yay. All right, so what we're going to do today, solving matrix equations, easy peasy lemon squeezy, multiplying two matrices, medium difficulty about there, and then word problems, which, word problems are word problems. Okay, you don't need to copy down this slide. You can take a picture of it if you want. All this is telling you is that a lot of the rules you've used in Algebra 2 apply equally to matrix addition and scalar multiplication. So the commutative property works. A plus B is the same as B plus A. The associative property tells us it doesn't matter what order I add if I have three matrices. I can do B plus C, then add A, and get the same answer if I do A plus B first, and then add C. Same thing with scalar multiplication. If I multiply my two numbers and then multiply by the matrix, I'll get the same thing if I did it one at a time. The identity for scalar multiplication is 1, because 1 times anything is itself. The additive identity is not 0, it's the 0 matrix, which is filled with zeros. So A plus the 0 matrix would just give you A, because for every element you add A. And then we already talked about this one yesterday, but the distributive property works. I can multiply my scalar through the parentheses. Okay, now let's get to the meat and potatoes of the lesson. The reason why this is important to say is because it turns out that this isn't true, or at least not all of these are true for matrix multiplication. It is not commutative, and the rules are slightly different. So be ready for that. Okay, so subpoint B. How do you solve a matrix equation? It's actually not too bad. So let's say I have this equation where X, A, and B are all matrices, and I want to solve it for X. I know what matrix A and matrix B is. I need to get X by itself so I can figure out what it is. And it works almost exactly how you think it would. If I want to get rid of the plus A, what do I do instead? Subtract. So I get 3x is equal to B minus A. Here's where I say works out almost exactly like you would think. To get rid of this 3, normally I would think you would divide by 3, but there's no such thing as scalar division. It's not an operation. If you try to use your calculator and you take a matrix and divide it by 3, it'll tell you you can't do that. So here's what you do instead. You multiply by a third. I know what you're thinking. That's the same thing as dividing by 3. And you're right, but multiplication is defined, so we get to do it. So as long as I type this into my calculator, it will give an answer. If I type in B minus A divided by 3, it will tell me undefined. So it's just a weird little thing that we have to live with. There you go. That's the only difference. That's my next. Well, actually, I'm gonna have you do it first, and then I'm gonna. That's 2 slides from there. I want to show you by hand first. All right. So if we do this by hand, b minus a would be -3 minus 1 is -4. 4 minus a -2 would be really 4 plus 2, so that's 6. 2 minus 0 is 2. 1 minus 3 is -2. All right, and then I want to multiply all of that by a third. So we'll get -4/3. 6 divided by 3 is 2. 2/3 and -2/3. That is x. Yay. So again, it works exactly how you would think it would work. You just subtract, but instead of dividing, you do multiply by 1 over the number. I don't know, you would think that they would have fixed that by now, but they haven't. If you try to type in, it'll say error. I think you could probably program it to fix that, but I get it. And actually, to be honest, when you're solving matrix equations, you probably won't want to use a calculator. You can do this with a calculator, but you'll see it's a lot more steps than you probably want to do anyway. All right, anybody need more time on this slide? Okay. All right, your turn then. Solve 2x minus a equals b, where a is this matrix, b is that matrix. I'll give you 3 minutes.
Like the equation.
Like, what would you have to do to A in order to make it into B? No. The only thing that ends up being kind of like that is I'll give you two matrices and I'll say these matrices are equal if this element is 5 and this element is 2x, what's x? So you would write like 5 equals 2x, divide both sides by 2. That's the closest thing. Yeah, that has that in the homework. But yeah, I think that's the only thing like that. Yeah, pretty sure. Okay, all right, what do I do first? Add A. So we get 2x equals B plus A. Now what do I do next? Times by a half. So we'll get x equals a half of B plus A. And B plus A is what 10, 0, -2, 8. So then a half of that would be 5, 0, -1, 4. Okay, hold on. Maybe we'll do something like that, but it's a very specific one. I might say, all right, you tell me what you need to do to A in order to change it to this. That. Okay. Well, to be honest, that's part of the reason why I jump around the book the way I do, is because I also hate how the way it teaches you to do that. So I'm gonna show you how to do that using what I think is a much easier way to do that, rather than doing the algorithm that it gives you. I'm gonna show you how to do it with determinants, and that's a lot easier to do with determinants. So that's why after 7.5, we go to 7.7, and then we go to 7.6. So I think we might do 7.5, 7.7, 7.8, then 7.6, then 7.4. Okay. Just because determinants are a lot easier way to do everything that they want to do. And they save it for last for, I don't know. I don't know why. But let me show you how to do this with your calculator. So let me stop share, whole screen. Okay, so if you get out your calculator, it's really not too bad. It's a lot of button presses is what it is. If you hit second inverse key, it'll let you open up the matrix part of your calculator. You'll see that it says matrix right there. Yes. You get to unlock some new buttons today and know how to use them. It'll give you a list of matrices. Yours is probably blank right now. It doesn't have anything here. This is where you would pull matrices to use in different calculations. Before you can really do that, though, you need to edit them. So you need to go right twice to the Edit tab, and then hit Enter. It'll ask you the size of the matrix. So this is you can see I already type it in. It's a 2 by 2. And then it'll ask you to fill in all the elements. So I type it 6, 1, 0, 3. And if you ever mess up, you can use the cursor to navigate between the cells to fix any mistake. All right, what is kind of annoying is you can't just like go back to the screen you were just at. You have to quit entirely. So hit second mode to quit out of it. Can't you just go back to second? No, because if you try it, it'll pull up the matrix thing again. It'll look like you're doing the right thing, but when you go to enter it, it'll take the matrix and enter it as an element in your matrix. And you have a matrix inside a matrix. And you don't want that. I know. I could be, hold on, let me check. I'm pretty sure that's what it does. All right, let me do that with B. So if I edit B to make it a 2 by 2, and if I hit second matrix right now, it'll pull this up. Oh, maybe it will work. What was I doing? What if I hit this? Oh, maybe it will. I totally just lied to you then. I know there's a problem with it. It's not there. There's a problem with it when you go to use it again. I did it earlier this morning. I'm going to find it. Okay, once you have them typed in, you can then type in what we wanted. So we want to do a half times, and I want a matrix A right here. So to get that, I hit second matrix, and then you hit enter now that it's typed in, and it'll copy the matrix there for you. Plus second matrix B. Maybe it has to do with determinants or finding inverses. I don't know. Maybe I just lied to you entirely. In which case, there are 3 hours, 3 lectures of precalculus. You have to do it the hard way now, and you don't. And then you hit enter and you get it. So again, that's a lot of button presses for something you could probably do faster by hand for this. But when you do, when you do matrix multiplication, it'll probably, when you do anything higher than a 3 by 3, probably be easier to do in your calculator. And when we do determinants and inverses, same thing. Oh, okay. All right, questions on the calculator? All right, well then let me show you what I mean by that. Matrix multiplication. So I'm going to describe how it works. It probably won't make a lot of sense until you see it in action. But here's how matrix multiplication is defined. You have to do something called row by column multiplication. And again, you won't need to write down this whole slide word for word. I'll tell you what you should have. The product of two matrices, A times B, where matrix A is an M by N, and matrix B is an N by P matrix, results in an M by P matrix, that's matrix AB, whose elements are found by multiplying the corresponding row in matrix A by the corresponding column in B, and then summing the products. All right, so what you need to write down. I would just write down this picture, and then that the elements are found by multiplying the row in A by the column in B, and the sum. So write down this, elements are found. That's what I would write. Just a step in the boxes. Because this diagram here tells you everything you want to know. If I want to take A times B to get AB, if A is an M by N, then B must be an N by P. The really important part of that is the number of columns in A has to be the same as the rows in B. These two numbers have to equal. And if they do equal, then the results will be an M by P matrix. To find what goes in that matrix, like if I want to find out what this element is right here, I take the row that it's in A, and I multiply it by the column that it's in B, such that I do like it. The first A times the first B, plus the second A times the second B, plus the third A times the third B, and so on and so forth. Again, the description is more complicated. Once you, after one example, you'll be like, oh, this isn't so bad.
I remember doing it last year. I was like, what do you mean that you make sure that?
Yeah, it's not that bad. Nope. I always forget that I have to re-unshare and share just the slide. But that's okay. I don't need that. Jake? All right. Let's see it in action then. So let's say I have A and B and I want to find their product. The first thing you always do is check the dimensions. This is a 3-row by 2-column matrix. B is a square matrix that is a 2 by 2. Do these two numbers equal each other? Yes. So then this operation is defined. If they didn't equal, I would just write undefined and I'd be done. Since they do equal, then my answer will be a 3 by 2. So AB is a 3 by 2 matrix. So I'm going to draw. Here it is. It's got 3 rows and 2 columns. All right, really this setup part is the most important part. If you get past this, I think you'll then just naturally be able to figure out the rest on your own. If I want to find out, well, what goes here in the first row and first column? To find it out, I will take the first row of A and I will multiply it by the first column in B. I take the first row times the first column. So that'd be -1 times -3 plus 3 times -4.
So you just added it in.
Exactly right. So that will give me what? +3 and -12. So that'd be 3 minus 12 is -9. Yay. All right, let's do that 5 more times to find out what goes here. In the first row, second column, I'll take the first row times the second column. So -1 times 2 plus 3 times 1, which is what? -2 plus 3, so that's 1, +1. Alrighty, 4 more to go. There we go. To find out what goes here in the second row, first column, I'm now going to take the second row of A. I'm going to multiply it by the first column of B. So 4 times -3 plus -2 times -4. So that'd be what? -12 and +8. So I think that makes -4. Second row, second column. Second row, second column. So 4 times 2 plus -2 times 1. 8 minus 2, 6. Isn't this better than therapy? You just sit and you can do this all day.
That sounds terrible.
No, this is great. All right, so third row, first column, third row, first column. I have an ASMR channel on YouTube that's just me talking about these as people watch me solve it. They go, wow, I just feel so relaxed. Just look. 5 times -3 plus 0, yay! That's at -15. Last one. Third row, second column, third row, second column. 5 times 2 plus 0 times 1. We get 10. And that's A times B. Done that in no time at all. Now imagine if we had to multiply that by 2 by 8. No. And then you grab the calculator, you just type it in, multiply, hit enter. Yeah, once it gets past 3 by 3, even 3 by 3 is kind of a stretch. If you do a 3 by 3 times a 3 by 3, 3 rows, 3 columns, 3 rows, 3 columns, you end up doing it what? 3, 6, 9 times 3, 27 multiplications and additions. That's a lot of fun. All right, clear this. It's your turn. And look, you get to do 2 of them. It's like winter break came early again. Find the product of A and B for both of these. Oh, hold on. Stop share. Reshare just this screen. You don't. Well, I explain some calculus. All right, let's do it. So first thing you'll do is label. This is a 3 by 2. This is a 2 by 2. This is a 3 by 2. And then this is a 3 by 4. So for the first one, notice that the 2 and the 2 match. So it is defined. The answer will be a 3 by 2. All right. To find it, I take the first element in the first row, first column. I take the first row times the first column. And that's actually a pretty easy multiplication to do, right? That's -1 times 1 and 4 times 0. So that's just -1. I'm going to go ahead and finish out the first column then, because that seems pretty easy. So then this would be 2 times 1, 2. And then this would be 1 times 1 plus 0, which is 1. Notice that what happened there, this formation is actually really important. This 1, 0 made it so that I just took the column in A and I copy and pasted it. That's important. We'll talk more about that later. To get the second column, I'm going to take the second column and I'm going to multiply it by each of these rows. So -1 times -2 is +2. 7 and 14 makes 28. So I believe that gives us 30. Second row, 2 times -2 is -4. And then we get 0. So the answer is -4. Last one. 2 times -1 is -2. 2 times 7 is 14. 14 minus 2 is 12. Yay. What about this one? Nothing. That's right. These numbers do not equal, which means that this is undefined. Let's, for fun, we did A times B. Let's do B times A. So B times A would be a 2 by 2 multiplied by a 3 by 2. But that doesn't work either. So you can see pretty clearly that it's not commutative, not a commutative operation. A times B is a very different answer than B times A. A times B gave us an answer. B times A gave us nothing, undefined. So that's a very big point that you should take away from today's lesson, and that is used to test you on the ACT. Go back. Which of these operations is not commutative? It's always the matrix multiplication. Also, matrix multiplication giving you an undefined answer. They'll ask that a lot because that's a question that takes under a minute, right? Whereas like doing this, it's pretty close whether or not we did that in a minute or not. These questions are always under a minute. So they'll ask like, find the product of these two massive looking matrices. And you might be like, oh my gosh, I have no idea how to, oh wait, I just can't do it. It's undefined. Stressing about time, there's no need. All right, questions about this slide? Okay, so again, here's some properties. You don't need to write them down. They are a little bit different, so if you want to take a picture of them, that's fine. The associative property still works. The order that you write these in matters, but then the order you perform them doesn't matter. So if I do B times C first and then times it by A, I'll get the same thing if I did A times B first. This is kind of weird. The distributive property works, but you have to be actually very careful. You might be very tempted to see a problem like number 3 and then switch it so the C is in front. That's actually wrong. You can't do that, right? How this looks may look weird. That is how it has to look. And I can use distribute C through this, but when I do it, I have to make sure it goes at the end. So it's AC and then BC because the order matters. Leftwise, it's fine. When I distribute A, you can't do that. Just make sure A stays on the left. The associative property of scalar multiplication still works just like you would figure. And there is an identity matrix for multiplication. It looks kind of weird though. It looks like this. Let's do it for a 3 by 3. Looks like that, where there's ones along the diagonal and zeros everywhere else. That's what creates that pattern, so that when I multiply this by the first row of A for each one, it'll only copy the first number. This will only copy the second number. This will only copy the third, so that you end up getting just a complete copy of what A is.
Does it have to be that diagonal or just move
It has to be this way. Yep. So it has one along this diagonal and zeros everywhere else. That's the identity matrix. And that's the end of class. Okay. There's an assignment due Monday. It's like 6 to 10 questions. You can use your calculator to help you out and check for the multiplication stuff that you have to do. In fact, I think some of them tell you to use the calculator to do them. Just to make sure you know how. Because next time we'll talk about determinants. And for a 2 by 2, it's not too bad. But for a 3 by 3, we might want to use a calculator. All right. Have a good one, everybody. And I will see you Monday.